Page 15, finding cube roots. Study the example problems showing how to find a cube root and then solve problems 1 through 8. The example says each edge of a cube is x centimeters long. The volume of the cube is 343 centimeters cubed. What is the length of each edge of the cube? So they want us to go from volume to a single edge. Okay, we're going from a volume, 3 dimensions, to an edge, which is 1 dimension. Use the formula for the volume of a cube. V cubed is equal to, x cubed is equal to the volume. We're going to take out the V and we're going to replace it with 343, which is what they said the volume was. Now we need to know a single side. We don't want to know the 3 dimensions, we want to know 1. So we're going to take the cube root of both sides. The cube root of x cubed is x. And then we've got the cube root of 343. Now, you could factor that out. You could go to your graphic organizer that has your perfect cubes listed. Either way, you're going to figure out that x equals 7. So each edge of the cube is 7 centimeters long. Number 1 says, what is the relationship of the volume of the cube to its edge length? The volume is the edge cubed. They're just asking you what the relationship is. Put the formula into words. The volume is the edge cubed. Number 2, what is the relationship of the edge length of the cube to its volume? It's basically the same question. You're just going the other way. This time we're going to say that the edge is the cube root of the volume. The edge is the cube root of the volume. Now, you guys probably spent more time trying to figure out what those two questions were asking you than you really needed to. The wording of these questions makes it really, really hard. They're usually asking for something very basic. Number 3, the volume of a cube is 8 feet cubed. What is the length of each edge? So we have volume, which is 3 dimensions, and we want length, which is 1 dimension. Set up your equation. The volume is 8, and the formula for volume is equal to side cubed. So our equation would be 8 is equal to side cubed. We want to know the length of one side, so we'll take the cube root of both sides of the equation. The cube and the cube root cancel, leaving us with s. And the cube root of 8, which you should have memorized, is 2. 2 times 2 is 4, times 2 is 8. The cube root of 8 is 2. So the side length is 2, go back for your units, feet. Number 4, explain the difference between a number that is a cube and a number that is a cube root. A cube, I just want to point something else out. They gave you the definition of a cube root. They gave you the definition of a perfect cube. These definitions are basically what they're asking here. A cube is 3 factors of a number. Let's put the product. The product of 3 factors of a number. Okay, a cube is the product of 3 factors of a number. A cube root is the base factor. Okay, it was the number that was multiplied together. On the next page, the top of page 16, we're at number 5. You can use prime factorization to find a cube root. You can use prime factorization to find a cube root Complete the prime factorization of 64. Now, I told you guys on that on the factor trees, I like to start with 2. That does not mean you have to start with 2. Okay, you can start with anything. I just do it because it makes mine nice and neat. Theirs is still neat. They just actually did a little extra work. They started with 8. 8 times what is 64? 8 times 8 is 64. And then from 8, they said that 2 times 4 makes 8. If 2 times 4 made 8 on the left, 2 times 4 makes 8 on the right. The 2 stays the same. The 4 factors into 2 times 2. The 2 stays the same, and the 4 factors into 2 times 2. Now, in the last class, we realized that B is actually a typo. It says show the prime factors as 3 equal groups of 2 factors. They have this backwards. It should be 2 equal groups of 3 factors. And then we're just going to rewrite this over to the side because they messed up. Okay, it should be 1 group, 2 times 2 times 2, and then a second group of 2 times 2 times 2. Okay, they wrote that backwards because the cube root of 64 is 4. 1 2 to represent this group, a second 2 to represent this group, and 2 times 2 makes 4. Okay, they just had it backwards. It's not a big deal.
I need a member of ABM to report to the office, please. A member of ABM.
Number 6. Is 48 a perfect cube? Explain your reasoning. The answer here is no. And the reason is 27 is the cube of 3. And 64 is the cube of 4. Since 48 is between 27 and 64, then that's going to have to be 3 point something, which makes it not a perfect cube. It is between, not perfect. Okay, it is between 2 perfect cubes, which makes it a decimal, which means that it itself cannot be a perfect cube. Number 7, explain how a cube root is different from a square root. A cube root takes 3 factors. A square root only takes 2. Okay, a cube root takes 3 factors. A square root only takes 2 factors. Number 8, the volume of cube A is 216 cubic inches. The length of each edge in cube B is 2 inches longer than the length of each edge in cube A. How much greater is the volume of cube B than cube A? If you want to compare cube B and cube A, you need to know the volume of both. We only know cube A. We can't find the volume of B until we figure out its side length. Cube A has a volume of 216 inches cubed. We can use the volume to find the side length. Cube B is still going to have a side length, but we're going to increase it by 2, making it bigger, okay, S plus 2. Once we know S, we'll be able to solve for cube B. This is A, this is B. So 216 equals the side cubed. When you take the cube root of both sides, your side equals 6. That would be 6 inches. For cube B, 6 plus 2 makes 8. So it would be 8 by 8 by 8, or 8 cubed equals the volume. 8 times 8 is 64. And when you multiply that by 8 again, you get 512. Now they wanted to know how much greater B was than A. So 512 minus A, which was 216, gives you 296, I believe. 296 inches. We're still talking about volume, so it is still inches cubed. And that's it for question number 8. All right, top of page 17, we've got an example. He walked halfway around the park. That was had an area of 90,000. They're showing you all of their work. The side length was 300. He walked halfway around. That's 2 of the sides. 300 plus 300 makes 600. A smaller square park has an area of 3,600 square meters. What is the length of one side? We have area, which is 2-dimensional, and we want to know the side length. Take the square root of both sides, and the square root of 3,600 is 60. It was square meters, so it is just meters. Number 2, when completely full, a cube-shaped container will hold 8,000 cubic centimeters of water. What is the length of an edge? So we've got a volume, and they want an edge. So side cubed equals 8,000 would be the volume. We want to know one side, so we take the cube root of both, and we get 20. And that would be in centimeters. Okay, the side length is 20 centimeters. Number 3 is a little tricky. A planter in the shape of a cube has a volume of 1,000 inches cubed. Is the area of the base of a cube greater than or less than 1 square foot? We've got a volume that's given to us. So side cubed equals 1,000. We want to compare the area. So we're going to go all the way down to side by taking this cube root. And the side is equal to 10. So the area, side squared, would be 100. Now think for just a minute. The side length of this planter was 10 inches. Okay, 10 inches by 10 inches. They want to know, is it less than or greater than a square foot, which would be 12 inches by 12 inches. So is it going to be greater than or less than? It is going to be less than, because 10 inches is less than 12 inches. Okay, the planter is smaller. It is going to be less than. Less than. The side squared for a 1 square foot would be 144. Number 4 is the same question that was in the examples in our instruction book, so we're going to skip it. Number 5, the area of the top face of a cube is 9 square centimeters. Use 9 of these cubes to make a rectangular prism. So the top of the box was 9, and they want us to use those to make a rectangular prism. The only way to do that is to line those up as one column, like so. And then your area would be length times width times height, or 9 times 1, which is 9. And that is in centimeters cubed. So the area was 9 centimeters squared. The volume is 9 centimeters cubed because of the shape of that prism. Number 6, we've got a total area here of 233 square feet. This smaller square is 64. If we subtract that, we get 169 for the larger square. To find each of the x's, we take the square root because it is surface area. Gives us 13 by 13. And then 13 plus 8 gives us a long side of 21 feet. And she just wanted to put railing along that long edge. So she needs 21 feet of railing.